Ground start circuits must maintain correct polarity to function. CA and CCS in telecom TDM, time division multiplexing, networks, voice signaling is categorized into two main methods, CA and CCS, based on whether the signaling information travels along the same path as the voice traffic. One-channel associated signaling, CA is a traditional signaling method where control information, like call setup, teardown, and line status, is permanently associated with each individual voice channel. Operation, in CA, signaling is often in-band, meaning it is embedded within the voice channel itself. Technique, a common digital form is robbed bit signaling, RBS, on T1 lines, where the least significant bit of every 6th and 12th frame is robbed for signaling purposes. Examples includes legacy analog methods like loop start, ground start, and ENM, ear and mouth, signaling. Limitations, it is relatively slow, inflexible, and susceptible to fraud since users can potentially inject signals into the voice path. Two common channel signaling, CCS. CCS is a modern, packet-based signaling method where a single, dedicated channel carries the control messages for multiple bearer, voice, channels. Operation, signaling is out of band, meaning it is sent over a separate, high-speed channel, often 64 kbps, distinct from the bearer channels carrying the actual voice. Efficiency, a single signaling channel can typically manage signaling for thousands of traffic circuits. Primary examples, SS7, Signaling System 7, the global standard for core network signaling. ISDN PRI, used for business connections, for instance, AT1 PRI uses 23 B channels for voice and 1 D channel for signaling. Benefits, offers much faster call setup times, higher security, and the ability to transfer complex information like caller ID. Comparison summary: feature channel associated signaling, CA, common channel signaling, CCS, signaling path in band, same path as voice, out of band, dedicated channel, speed relatively slow, very fast, security lower, open to fraud, high, separate signaling network, efficiency 1 signal per traffic circuit, 1 signal for thousands of circuits, key standard R1, R2, MFC, SS7, ISDN. CA and CCS are used in different parts of telecommunications networks, with their usage often depending on the age and scale of the infrastructure. Where channel-associated signaling, CA, is used, CA is primarily used in legacy systems or smaller-scale environments where simplicity and cost-effectiveness are preferred over high-speed. Older telephone systems, CA is a foundational technology for managing calls in traditional public switched telephone networks, PSTN. Small businesses and PBXs, it is used for connecting private branch exchanges, PBXs, to the main network, especially in systems utilizing T1 lines with robbed bit signaling. Specific regional networks, while many global networks have modernized, CA, particularly the R2 protocol, remains in use in parts of Africa, South America, and Europe. Specialized devices, technologies like fax machines and some radio broadcasting equipment still utilize CA to transmit control signals alongside audio or data. Where common channel signaling, CCS, is used, CCS is the global standard for modern telecommunications, used where high-speed call setup, security, and advanced features are required. Core carrier networks, CCS is the primary method for interswitch communication in modern telephone exchanges. Global SS7 networks, the signaling system number 7, SS7, protocol, a form of CCS, is used worldwide to handle call routing, billing, and roaming for both fixed-line and mobile cellular networks. ISDN connections, integrated services digital networks, ISDN, use CCS, the D channel, to manage signaling for multiple B channels, voice/data. Modern voice over IP, VoIP. While VoIP uses newer protocols like SIP, CCS, and its evolution via SIGTRAN, provides the bridge for interconnecting VoIP networks with traditional PSTN systems. Advanced telecom services, it powers features like caller ID, toll-free, 800, numbers, and real-time fraud protection. CA in T1 and E1 in TDM networks, channel-associated signaling, CA, fits signaling bits into frames differently depending on the standard used, T1 versus E1. The fundamental difference is that T1 robs bits from voice data, while E1 uses a dedicated time slot within the frame. 1T1 networks, robbed bit signaling, RBS, in North American T1 systems, CA uses robbed bit signaling. Instead of having a dedicated channel, the system steals the least significant bit, LSB, from the actual voice data in specific frames. Superframe, SF/D for a group of 12 frames. Signaling bits are robbed in the 6th and 12th frames. A bit, stolen from the LSB of every channel in frame 6. B bit, stolen from the LSB of every channel in frame 12. Extended superframe, ESF, a group of 24 frames. Signaling bits are robbed in the 6th, 12th, 18th, and 24th frames, allowing for more complex states. These are referred to as the A, B, C, and D bits. Impact: because only the least significant bit is changed every sixth frame, the impact on voice quality is negligible to the human ear. However, it reduces the reliable data rate of a channel from 64 kbps to 56 kbps because the eighth bit is no longer clean for data. 2 E1 networks, dedicated time slot, TS16, in European and international E1 systems, CA does not rob bits from the voice channels. Instead, it uses a specific time slot to carry signaling for all other channels. Time slot 16, TS16 and E1 frame consists of 32 time slots, 0 to 31. TS16 is strictly reserved for signaling. Multi-frame structure: 16 frames, numbered 0 to 15, are grouped into a multi-frame. Frame 0, TS16 carries multi-frame alignment information, to keep the receiver synced. Frames 1 to 15, TS16 is split into two 4-bit sections. Each 4-bit section carries the ABCD signaling bits for two specific voice channels. Impact: since no bits are robbed from the voice channels, each bearer channel provides a full 64 kbps of clear bandwidth. Comparison table feature T1 CA, robbed bit, E1 CA, TS16, method bit stealing from voice channels, dedicated signaling time slot bit location least significant bit, 8th bit, all bits of time slot 16 frequency every 6th frame, A/B or A/B/C/D, every frame, except frame 0, voice bandwidth 56 kbps, effectively, 64 kbps, full clear channel, signaling bits A, B, SF, or A, B, C, D, ESF, A, B, C, D. CCS in T1 and E1 in common channel signaling, CCS, signaling bits are not scattered or robbed from voice samples as they are in CA. Instead, a dedicated, high-speed time slot, channel, is assigned to carry all the signaling messages for all the other traffic channels in the link. The assignment depends on whether you are using the T1 or E1 physical standard. 1 CCS in T1, North America/Japan, in a T1 environment, CCS is most commonly implemented as ISDN PRI, primary rate interface. Channel count: AT1 consists of 24 time slots, channels. The D channel, in a CCS configuration, time slot 24 is assigned as the data, D, channel. The B channels, the remaining 23 time slots, 1 through 23, are used as bearer, B, channels for voice or data. Structure: this is often referred to as 23B plus D signaling type. The D channel runs at 64 kbps, clear channel, providing a high-speed path for 931 Quetzales call setup messages. Unlike T1 CA, the B channels remain clean at 64 kbps because no bits are robbed. 2 CCS in E1, Europe/International, in an E1 environment, the architecture is slightly different because the frame naturally contains more time slots. Channel count: an E1 consists of 32 time slots, 0 through 31. The signaling channel, in CCS, time slot 16 is assigned to carry the signaling information for the entire trunk. The B channels, time slots 1 through 15 and 17 through 31 are used as bearer channels. Time slot 0 is always reserved for framing and synchronization. Structure: this is referred to as 30B plus D, or 30B plus 1s. Signaling type: like T1, this is a clear 64 kbps channel. Whether it is used for ISDN PRI or SS7, signaling system number 7, time slot 16 remains the dedicated path for all control traffic. Summary comparison of channel assignment feature T1 CCS, ISDN PRI, E1 CCS, ISDN/SS7, total time slots 24-32 assigned signaling slot time slot 24 time slot 16 user, bearer, slots 1 to 23 slots 1 to 15 and 17 to 31 standard configuration 23B plus 1D 30B plus 1D signaling bandwidth 64 kbps 64 kbps. Note on NFAS, in advanced T1 CCS configurations, you can use non-facility associated signaling, NFAS. This allows one D channel on a single T1 to control the bearer channels of multiple other T1 trunks, effectively turning the 24th slot on those secondary trunks back into voice channels. Details on NFAS implementation can be found in Cisco's ISDN documentation.